There's just a close-up of showing our pile tip, our reinforced, hardened tip. Sometimes they're welded on in the field, sometimes they're welded at the factory. But you definitely want to look, when you're looking with H-pile, if there's a pay item or tip. That's how we know if there's supposed to be tips on H-pile or not, if there's a pay item. If there's no pay item, no tips go on H-pile. Orientation of a pile, when we look at our plans, it's important to understand and know which way your piling are going to go. Anybody have an idea why we would put it this way to be a strong way? What kind of abutment would we build, per se? Being the strong way. Is our abutment going to move if we put piling in this way? Do we think our abutment's going to move? It's going to flex? It's not going to, because it's stiff, right? We got it the strong orientation way. So now we get to an integral abutment. What do you think? Weak way. Everybody know how an integral abutment works? Everything's the beams, the bridge slab, everything's tied into the abutment as one assembly. So when the bridge expands and contracts, our pilings are going to flex. So the whole bridge is flexing on the piling, being the weak way. So now the stiff way, that's separated where we don't want the bridge, the abutments to move. They're going to be rigid, and the bridge is going to move within the abutments. That's why we have the expansion joints, right? If you don't have an expansion joint on your bridge deck, 9 times out of 10 it's going to be integral, right? Because everything's going to be tied together all the way down to our foundation. So it's really important when you're looking on your plans, when you're inspecting, that you get the piling in the correct orientation. And it has happened where the piling has been put in the wrong location on bridge projects. So it's really important to understand and know the orientation of your piling. So if you look at this, nice straight line, what type of abutment do you think that would be?
Integral.
What's that? Flex or integral, right? Because the piling is in our weak direction, right? It's important that we get them in a nice straight line, right? Because we put these in here, we put our rebar in here, we need a nice straight line so we can encapsulate that in our rebar. If we get them out of orientation, when we talk about tolerances, when we put piling in the ground, we have a tolerance for the final resting place the piling can be for that reason. Because if we get them out of whack, you know, we get them one over here, one over there, one twisted sideways, do you think that foundation is going to move? You're probably going to lock it in place. So when we talk about piling, anybody know what the 12 by 63 means? "12 inches in pounds, right? It's 12 inches out to out, and it weighs 63 pounds a foot. So when you get bigger piling, heavier piling, you may have a 12 inch by 84, or you might have a 14 by 72. It means it's the dimension out to out, and it weighs the weight per foot of that pile. So everything designated when you look at your plan sheets, it's a designation HP 12 by 63. Whatever specific for your project is, it'll identify that piling size. CIP piles. Drive it in the ground, cut it off, we fill it with concrete. It's a type grade 3 with a yield strength of 45 KSI. How do we know that? Where do we find that information for shell pile? Specs, right? Next page. 3371, 3372. Then you have shell pile. $33.71. then you can see the table on there, your requirements for your pile size, the minimum requirements, the diameter of the pile you have. And that's another thing you have to watch for in your plan sheets, is what size your shell pile and your wall thickness. It's not always going to be a 1/4 inch. You could have 5/8, 1/2 inch, 3/4, 1 inch pile. And you got to remember these numbers when we talk about yield strengths. For CIP, it's 45 KSI. Later on, we'll come back around to it, but remember these yield strengths for your piling. About 70% of all the piling or the bridges built, we use shell pile. And you can see here's a conical point. We want to drive it down, get it deeper. Maybe we have a little cobbles, little something in the way that we want to try to punch through. So sometimes we'll call for these cones. If we call for anything else other than a flat shoe for a shell pile, it will be a pay item. Otherwise, the standard practice, every single piece of shell pile you put in will have a flat plate on the end of it, unless it's called for something else, like a conical point. So every shell pile will have a plate on the end. When you get into bigger diameter piles, we have some open-ended stuff where we don't plate them, but that'll be in the special bridges, bigger piling, 20, 30-inch piling. But on your everyday standard bridge, you will have a plate on the end of it. So this is about a 90-foot pile length. How many fishermen we got in here? Ice fishermen. How many have cameras for ice fishing? Nobody? So I'm an ice fisherman, I have a camera. They're a great tool to use at work because you can drop them down these piles and do an inspection. That's one of your requirements. After the pile is driven, is you have to inspect the inside of the pile to make sure it's not damaged. So you can see in this picture, we used the camera, we sent it down there, and at 62 feet, we have a collapsed pile in there. And the other thing we do for inspection, when we annotate our length of the pile we put in the ground, we want to drop a tape measure down inside of here to make sure it matches. That if our paper says we put 60 feet of pile in the ground, we want to put a tape measure inside to make sure there's 60 feet of piling there. Because then this will happen. This is the end of the pile, the bottom of it. You get a little collapsing. This is very minor, it happens, but we need to measure that to make sure we document that if this pile has failed. With this would not be considered a failed pile. It's still sealed, you don't have water coming in, it's dry, so that's still a good pile. One of my pet peeves on projects is garbage. Contractors like to put welding rods, pop cans, stuff into piling. I don't like that, I don't like garbage being buried on projects. That's my pet peeve. So, when we're driving shell pile, again, we're using friction, right, to grab that pile to hold it into place. Sometimes we'll have in our plan sheets that we have a redrive. That means we're going to wait 24 hours after we drive it for the soils to grab that to increase our bearing capacity of the pile. We can get up to 20-25% increase pretty standard on our piling setup. We'll talk more about that a little later on too. Just breezing through here. Precast concrete. I think we have one bridge in the state of Minnesota that uses precast concrete. We don't use it much in Minnesota because we have to go deep, we can't splice them, and we have to be careful when we drive them because we'll wreck the tops of them. But we do have one bridge, you can see here, concrete piles. It's on Trunk Highway 59. Monotube piles. So you can see monotube. Look at all the surface area on there with all them wrinkles in there, crinkles in there. Usually we don't use too many of these in Minnesota anymore, but they're out there. They're a high capacity pile because if you look at a regular round surface, you have less surface area with a true round pile versus this, because you have all these different surfaces, you have more square inches of friction on them. So we like to use these on high capacity piles. They're fluted, they're tapered, so when you splice them, you don't have to weld them, you just put your bottom in, put your next one on, and just keep adding on and keep driving. So your point on your first stick, say it's a 30-foot stick, it might only be 8 inches in diameter. But by the time you get to the top of a 40-foot stick, it might be 12 inches, 14 inches. And then you just add your pieces together. So you can see it's just a friction fit splice is all it is on there. Just some more pictures. So you can see here, say this is probably 8 inches on the bottom at the tip. It's pretty substantial big at the top. Example, driving pile on project using fluted pile. Look at there. There's our cofferdam.
Not very dry.
Not dry, not yet. So remember the stages how we built the cofferdam, put the sheet piling in, then what's our next step? Before we seal it. Before we pile drive. Put the sheeting in, we gotta dig it out, right? We gotta get to our elevation, right? And then we drive our pile, and then we pour our seal. And then we can pump it out. Because we can't drive pile through concrete, especially if you have a seal slab that's 10, 14 feet thick. So again, sometimes we'll have a pay item as a redrive, and sometimes you won't have a pay item as a redrive, but a redrive is always a tool in your belt that you have that you can use. Like I say, we'll talk more about redrives. Function of a pile. Anybody name functions of a pile? What do we call our piles? What do we name our piles? Foundation pile. What other piles? Type of pile do we have? Test pile. First pile we drive on a project. So our test pile. We have boring logs. Boring logs are never in the exact same spot we're going to drive a pile. So we're going to drive a test pile. It's our feeler piles. We're going to see what's down there. We're going to see how this pile is going to dry. So we call it our feeler pile to get actual data of what our substrate is. Then our non-test piles typically are our foundation piles. So in this picture, we can assume that this is a test pile, this is a test pile, and these are our foundation piles. So we're driving for a pile bend. We don't typically galvanize the full length of piling. You can see these are probably 90 foot piles. There's no point in galvanizing the bottoms. So we just galvanize the top sections. And the other thing on here, when we're driving pile bends, you're always in a nice straight line. So we use a template. We want to keep them in a straight line the best we can.
Does galvanizing work better than painting, or what do you think?
Say that again?
Is the galvanizing better than painting?
Yes, because, I would say yes, because the galvanizing is a heating process that embeds the galvanizing into it. And we've all seen the rattle cans of galvanized paint, right? Epoxy paint. We don't like that stuff on our project. They got to use a special hot zinc coating process. I can't think of the name of it right now. But when they do this, when they weld these and they're exposed, they have to do this hot zinc application in the field over their weld. Because generally where they're going to splice, they'll be a foot above or a foot below of a splice on a galvanized pile. So then they have to hot zinc that. Basically they heat it up with a torch, and they got a zinc stick that they're smearing onto there to coat that, almost like soldering, but they use a zinc stick to get the zinc back onto that. Paint, you know, we all see it in the water, it stains, it washes away, stuff bounces off of it, it wrecks the paint. So paint's not a good system for piling. How many people, the county, city and stuff are seeing deteriorating piling on their bridges? Now, you know, and them have been uncoated for 30 years, 40 years, and now we're getting our low water lines that are dropping lower than they have been, and we're exposing the water line piling, and there's nothing left to steel on them piling. So we're trying to take avenues to protect that, whether we do galvanizing, we put a second layer of protection like a fiberglass wrap or something to protect that. Sheet piling. There it is. Big weir wall out in the ocean for boats and ships to bounce off of. We want to use it to hold back soils. You know, in this condition, we're working on the soil side to keep it out of the water. Most conditions we work in, we work on the inside. We want it dry. So here's an example of a project. We got all this sheet piling. Kind of looks like we're out in a swamp, as muddy, as wet as everything is. But look at here. There's a row of sheet piling in here, right? So we use this as our temporary work, and the plan probably must have called for permanent sheet piling, because they put it in, they cut it off to an elevation, and it's incorporated into their footing in there. So there must be a water problem where they don't want the water to come from the outside, to come up and get underneath this footing. Types of pile hammers. Name types, I think there's 5 types of pile hammers. Diesel. What was that? Drop hammer. Vibratory. There's your typical diesel pile hammer that we use in the state of Minnesota. Right there. So we have the drop hammer, single acting hammer, diesel hammer, double acting, and the vibratory and sonic hammers. Original pile hammer consisted of a steel ram raised to a certain height and allowed it to free fall, drop, gravity. Single acting hammer. We don't see too many of these around Minnesota. Like I said, the diesel's probably the #1 go-to hammer now. But basically, power drop hammer is the striking part. Put the air in, it lifts it up, and it drops. It uses steam or air, comes in here, lifts it up, and then it drops, using steam or air. So you can see, just to close up how this works, you inject it into here, it lifts this up. Here's your ram or your piston down here that strikes the anvil, that strikes the pile. Just a single acting, you put air in, raises it up, dumps it out, and it falls. Diesel hammers, this is set up on an excavator rig. Generally we'll see them on cranes, what we use here. So, how it works, just like your car engine. Same way. So, we use the crane, the third line, we're going to raise the piston, we're going to raise it up. As the piston's going up, fuel is injected into the system. This comes up, it trips, and it falls. Diesel ignites, it hits, diesel ignites, sends the piston and the ram back up. It starts the cycle all over again. So it's just a single cylinder diesel hammer running. The only time you use that third line is to start the hammer. Other than that, it drops, it fires, and it's just a continuous motion. Until you shut the fuel off, then it stops. So here you can see the ram coming out of the top of the cylinder. This is the ram that moves, that makes your energy when it hits. These can weigh from a couple thousand pounds to 60,000, 70,000 pounds. These rams going up and down. We had a big Delmag something. I'll have a picture of it. A big Delmag, and the piston alone weighed 78,000 pounds. Going up and down inside of that hammer. When we identify a hammer, when we talk about weep analysis or a hammer qualification for your projects, you're gonna see numbers stamped right into the cylinder on that. You have to verify with your weep analysis that is the same hammer that they did the study on. Here's your cylinder, your anvil, your helmet, and your piling. So the piston is inside of here, the ram is inside of here. It's this, it's that, it's the helmet, it's the pile, and drives the pile in the ground. Has everybody seen a pile hammer driving? Hopefully we can get a video to work here today. So there's your pile cap. So this is something you want to look at when your piling shows up, piling and the piling hammer shows up on your site. You want to make sure this is the correct size for your size of piling. We don't want this too big because then it'll flop around in there, it'll wrinkle or crease the top of your piling and it could adversely affect your pile driving. So this is a uniform cap. You can see we can use shell pile in here, and then we can use H pile in there. Pretty typical cap or helmet we call them that you'll see on a project. Fuel settings. So when this is laying on the ground and you're looking at this, there's going to be a cable coming, generally 2 cables, one on each side, and you got this little pointer right here. And when we talk about our hammer qualification, sometimes it specifies a fuel setting, 1, 2, 3, or 4. And that's where it's important. We have to verify that we're on the correct fuel setting. And it's just as simple as the pile buck will click it all the way to the left. He'll pull this cable down, pull this little pointer all the way to the left, which would be fuel setting 1, and then you'll click it to the right. So 1, 2, 3, 4. It's as simple as that. There's really not any numbers. If you look up close here, there's no numbers to differentiate what fuel setting is. You just got to go back to the first fuel setting and then bump it up from there. And it's good to look at it on the ground because generally it's 15, 20 feet in the air and it's tough to see where that's pointing at. So there's another close-up of that pointer right there. Again, there's no numbers there. But you just pull these, they got tag lines. Usually they have tag lines on here to adjust that fuel setting. Oh, there you go. Guess we don't get much video.
You don't have access to it.
Yeah.
Right?
Yeah, regarding the fuel setting, how do you tell are you washing the fluid or how?
Yep, so you're gonna stand there and verify when this pile, you can do it on the ground before they lift it up. Or once it's up, the pile buck will go up there and you'll pull this cable all the way and it'll stop. This pointer will go over to here. That'll be fuel setting 1. So now say your plan sheet or your hammer report says drive it on fuel setting 3. So then you're gonna come over here and pull this one. So you're on fuel setting 1, 2, 3. It's that simple. Just gotta pay attention to how many times they pull that. And if you're ever unsure of what fuel setting on, just tell them, hey, let's reset the fuel setting. Let's double check what setting we're on. And it's just a matter, it's like I say, sometimes they'll have tag lines and they can do it right at the ground. Click, click, yep, it's done moving, click it up. Double acting hammer. One more step than our single acting hammer, where we put power, steam, or air in it to lift it, and we put air or steam in it to push it down. Not too many of them we'll see not too many of them around. Vibratory hammers. 1, 2, 3, 4, 5, 6. That's a very large hammer, vibratory hammer. This is a typical vibratory hammer we use to install sheet piling. On any project, it's got a vise down here or a clamp. It's hydraulic driven. And they put their sheeting in there and they clamp it down and then they can install sheeting and they can remove sheeting. Sometimes if you have really long pile, if you have 100 feet of piling on a project, they may use these to put the first section in. It's a lot easier to clamp on a vibro hammer, put all your bottoms in, come in, weld all your add-ons on, and then put the pile hammer on. Because sometimes with that bottom section of piling you're putting in, the hammer may not start. And it could take you 20 minutes, a half hour, one hit at a time, trying to get that pile down. Yes, sir?
The gripper on the bottom is also adjustable.
Yes.
Once it bolts and it slides back and forth.
Yep.
So that's set up for a sheet pile right there. You can also slide all the way to one side, and you can measure the gap, and put another one on the other side.
Yep, put a second jaw on there.
Get a distance for tubular piling.
Yep, agreed, totally agree. And there is so much force on here, I don't remember if I have a picture of it in here or not. There is so much force on these jaws, they literally can weld themselves to the piling. And they have to torch them off to get the vibro hammers off.
Yeah.
They're so violent.
Ames is doing that project in Warren right now.
Okay?
They got 100-foot H-pile on the ground. It's like 14-inch H-pile. They literally grab out of that thing, mine it about halfway up, and then they pull it all the way up. Get the whole 100 feet in the ground, and they send a man lift up there, cut the bottom half off, and just by using those two.
Yep, it's
It's
violent,
crazy.
it's
Yeah.
so violent. Cause you know, this hydraulic line, there's eccentrics in here, I got a couple pictures coming up here. So there's eccentrics in here, off-center balanced weights basically, that are all off-centered, and them are spinning. So this is, you know, there's only 4 eccentrics on this one. We go back to this one, 1, 2, 3, 4, 5, 6. This thing is probably 10, 12 feet across.
It's also crazy loud.
Crazy.
It's 130 decibels can with about 15 through that.
Okay. Never measured decibels with it before, but that's good to know. Okay. Yeah, well, you can see that it's maybe the one they have up there.
That's the exact same one.
Yeah. We had the same one, this picture came from Dresbach, where we had 42-inch pile, and we had 2 jaws on that one. And we were literally welding them jaws. These are replaceable jaws in here. You can replace these. So it's a violent thing, and the ground does shake when you're around it. But you may see one of these on your project, probably maybe not as big, it might only have 1 or 2 eccentrics in it.
Would that affect like settling around the project too then, if it vibrates that intensely?
Not really, just in the immediate area.
Okay.
You know, you would maybe get some soils sloping down a little bit.
Because their lunch and undergrass is for the railroad.
Okay.
So they got monitors on either side of for the monitoring the vibration of the railroad.
Yep.
Like even 50 feet away, there wasn't much vibration at all.
Yeah, the soil really dampens it as it goes. And sometimes, like he says, when you're on these projects, say you're down, you could be downtown Minneapolis, St. Paul, you could be next to a historic structure. And like he says, you're gonna have vibration monitors that are gonna be specifically placed to monitor all your vibrations, whether it's a vibratory hammer, a pile hammer, whatever you're using to make sure you don't damage the surrounding structures. In Red Wing, we got what they call Barn Bluff, big bluff right there next to our project. We had sensors in the rocks on the bluff, so we didn't collapse or shave off the faces of the bluff. So here's a smaller one. You can see there's only 1 eccentric on there. Generally, depending on how long or how deep your piling has to go, your sheet piling will determine the size of these vibratory hammers or the sonic hammers. And what's the rule of thumb for the length of a sheet pile below grade?
There's no rule of thumb.
There is no rule of thumb. It's all engineered design. So the downfall with these vibro hammers is you have to have an external power source with hydraulics running to it. These hydraulic lines on these big hammers, they can be 3 or 4 inches in diameter, running hydraulic fluid. There's a picture of our eccentrics, our cut weights that just spin in there. I can't say how many RPMs, but they're spinning in there. Sonic hammers operate at a higher frequency than the typical vibratory hammer. And when we talk about piling, sometimes I'll call sheet piling just piling. shell piling, piling, it's all piling, whether it's sheet piling, H-pile, whatever, it's piling. Diesel hammers is self-contained, and again, the vibratories have external power source. Can we name 3 types of the hammer leads, pile hammer leads? Hanging, fixed, one more. Nope. What's that? Nope. Closed. Swinging. Somebody just said it. Swinging. What do the leads do? What's the intent of the leads?
Guide, I'm on
Guide the what?
guide, piling to the location for which.
Yep. A little more. Keep adding. Keep going on that. You're almost there. What other is the intention of the leads? Contain the hammer. We want to drive everything straight line. Guides the hammer, it holds the pile to be driven, drive the pile in a straight line. Typical 3 swinging set of leads. When we refer to leads, we're talking about this whole apparatus right here in green. That's our leads. And then we have our hammer, helmet, and our piling, and our gates, and static points. That's our leads. Guides the hammer to drive the pile in a straight line. Swinging, fixed, underhung, fixed, extended. The swinging is most common, what we use in Minnesota, because you're more freely to set your leads, where you can place your leads. With these fixed type, you've got to be right on spot to get to your final. What do you think? Pretty big set of leads. Big crane, lots of stick. See, now if we had a fixed, we'd have an arm coming out here attached to here, and this would be attached to there. You got to be a lot more precise with the fixed set of leads compared to the swinging lead. Here's our stabbing points. Pile buck will get the pile into the low spot it needs to be. They drop the leads or set the leads in the ground to hold the leads in place during driving. What do you suppose that number indicates?
Number of feet of pipe in the ground, piling ground.
Agreed.
Very cold.
That was a 100-foot stick of piling in the ground right there. What do you suppose that we're measuring here?
Battered pile.
Battered pile. Just a simple tool you can make for 3 to 12 batter when you have battered pile in your projects. So let's review this part of it. So name types of displacement or friction pile types. Timber, shell, H-pile could be, but we don't typically use that for a friction pile. Shell, pipe, monotube, or timber. What type of pile do we generally drive to bedrock? H-pile. What kind of pile is normally used to hold back soils, temporary or permanent, or we build a cofferdam with them? Sheet pile. See the common theme between all these? We call them all pile, right? So test piles are used for a blank pile to determine the length of our foundation pile. Feeler pile. Again, first pile we're putting in the ground, we want to know exactly what's down there, how our piling is going to drive. Name 2 of the 5 types of pile hammers. Diesel. What's that? Vibration. Drop. Single, double, diesel, vibratory, sonic. I have not seen a sonic hammer on any projects. I don't know if they're the cost of them, why nobody uses them, but I've never seen a sonic hammer on a project. What's the most common leads we use in Minnesota? Swinging. Any questions?
Yeah, I got, about, Cedar Pond, is it also considered as part of the pond? I mean, it's just in soil, but then we figure out, right, so you know, like, put it in the project.
What's the
The feeder pond.
Yep.
Yes, yeah.
test pile?
Yeah,
Yep.
it's automatically part of the project.
Yes, yep. So a test pile, when we pay for a test pile is always paid for as an each. Unless we're splicing on, we'll get into that a little later on, but test pile is paid for by the each. And you guys are so lucky that we only pay for piling driven below cutoff as a pay item. Back in the day, we had piling delivered, we had an authorized pile length,
Pile driven,
pile driven,
full cutoff.
below cutoff,
And then cutoff spliced and driven.
spliced and driven, MnDOT owned cutoffs, and contractor owned cutoffs.
That was bad.
It's,
Question.
sure,
So that project up in where that he was working on,
okay,
so they do the plumb with the swinging.
okay,
And then the battery one next to it, they'll put a chain on it, it's a 3-drum frame.
yep,
And they'll put a chain on the bottom of the hammer, and then they'll use one of the drums to pull it in and out to get the correct angle for the battery.
yep.
That's what we consider a swing, or that suddenly become fixed? Because
I would say it would be a swing because you can adjust the length at any moment in time. Where a fixed, generally it's a lattice work that you have to pull pins and you only have incremental, like 1 foot, 5 foot adjustments on a fixed. Where they attach the third line or fourth line to that, that's adjustable. It's still free swinging. They can flip flop it back and forth, but they can microscopically adjust that. So it would be still considered a swinging. What else we got? Anything?
I got a question on fuel settings.
Okay.
What if the weep analysis comes back on fuel setting 3 and the contractor says we never run like that?
That we never run like that?
Yeah, we only run it on 4.
Well, then you need to find a new contractor. Nope, that's the whole point of this weep analysis or this hammer qualification stating that you will run on this fuel setting. Because there's a number of things that are involved with this weep analysis, and we'll talk in depth later on. But to cover your question, so the weep analysis, when we drive a pile, we have to be below 90% of the yield strength of that pile. So what did we say shell pile was the yield strength of shell pile? So when we're driving that pile, we can only go to 90% of 45, which is like, what, 41.5 or something, 41? So when we're driving that pile, we cannot overstress that during driving. The other thing is we drive a pile between 30 and 180 blows. That's where we accept a pile driven to bearing has to be done between 30 and 180 blows per foot. So that's the two main things for that. So when you raise that fuel setting, you could be decreasing the fuel or the blows per foot, meaning you could be less than 30 blows per foot to meet the bearing requirement. But we say we need 30 blows per foot minimum to meet the bearing requirement. And the overstressing of the pile. We don't want to overstress that pile. Now there is situations, say when we have a PDA, a pile driving analyzer. That's sensors we attach to the pile and we read live data as the piling's being driven. It's measuring the stroke height, the stress is put on the piling by the hammer during driving. And when we have that live data like that, that might show us, hey, we're a long ways from overstressing the pile. We could go up to fuel settings for it, based on the PDA results. Kind of answer your question?
Yeah.
But yeah, the contractor's required, that's the whole point of the weep analysis or the pile hammer qualification is this is your parameters to do that. And it might make more sense when we talk about weep analysis, the requirements of that. So if I don't answer it in that, please ask me again.
Yep.
Anything else? I think that's it for this session. Let's take 5 minutes, be back 21 after 22.
three.
What was that?
What we did is we pulled down about 3 inches.
Yeah.
So we said, if we try to one to read the fire. The fire one, second fire, the fire one stay running. So then. Go ahead and start.